Hello there. Today we'll be doing the problem called bulk shift letters. You are given a lowercase alphabetical string S and a list of integers shifts. Each element shifts I means to shift the first li plus 1 letters of S by shifts I positions. So shifting a letter should wrap over Z to A. For example, shifting Z by 2 would result in a B. Because the resulting string, after applying shifts to S, return the resulting string after applying shifts to S. There may be up to 100,000 shifts. So let's take a look at an example to get us started. So we're given the string A, F, Z, and we have the shifts 1, 2, and 1. And our output is E, I, and A. The reason being is that we shift the first character by 1 position to get B, F, Z. Then we shift 2 letters by 2 positions to get D, H, Z. So the first 2 characters are shifted by 2 positions. Then we shift the first 3 letters by shifting 1 position of each. So a shortcut we can already see is to add up all the shifts backwards, because the last item will only get that particular shift. We get, let's say, 1 shift. The second item gets the next 2 items, last 2 items together, 3 shifts. And the n item gets all the shifts from all the items to totaled. So let's get that code together. So total equals 0. And for I in range of lang shifts, minus 1. So we start the end. We go to the end and we go by -1. And total plus equals shifts of I. And we're going to set the shifts to that particular total. So now we have the totals that we need. Next thing we need is that we want to find out how many numbers we're going to shift these letters by. A good way to shift this is using ORD to get the ASCII number. So let's start with the ORD of A, and that's our starting point. Because once we reach up to 12, we want to, not 12, a Z, we want to reverse back into that range where we start. So we're going to keep it within within the 26 characters, and then add it on to the start after making the shifts. That way we stay within range and generate the proper character. So let's set that word for every single item minus the start. It's for shifting. Then for I in range, we're gonna start shifting every single character now. So the new character is equal to the item plus the shift amount modulus 26. So what this does is that we look at the current location of the item. Let's say it's A, and we take it and we shift it 100,000 times. And we modulus that by 26 to make sure that we're basically subtracting 26 every single time. We're using division, and we're getting the remainder. So that remainder of the 26 is going to be our new character. So we're going to reuse our array to set our new character using char to convert our new character, adding the start, because it's only 26. We need to start 97, and set that character for every item. Once that is done, we will join our array together. Another way to do this is to have a brand new string and append to the string each time, but that will result in a new string being created each time, and a string is because the string is immutable. and creating a new string each time is, I think, might be more expensive. So we'll check that. So we're gonna run the results now. Let me shrink my screen, and let's see, it is successful. All right, so let's try that string method. So I'm gonna say build string is equal to empty string, and we're going to do build string plus equals the new char. So, and we're going to return the build string. Let's check it out. Same result, and it is a little slower than before, as you can see. So run it again, one more time. Oh, what's going on? It's getting slower and slower. So it started at 78%, 71%. Now it's down to 67. I'm not sure exactly what's the reason, but we don't want to do that. So that's all for this problem. If you have any questions or comments, please let me know in the comments below. If you enjoyed the video, like, subscribe, you know the drill. And if you want to see more, please look in the link in the description below to see my website, and it will have my algorithms and iOS information there. So thank you very much for watching, and have a good one.